Alright, for this particular problem, it goes ahead and it tells you the domain. Your domain for this particular one is 0 to 2 pi. So you have your number line here. Your number line is going to start at 0 and it's going to go to 2 pi. That's how it goes. Now we're ready to move on to the derivative. The derivative of this function would be 1/2 minus cosine x. 1/2 minus cosine x. There's no denominator, so you don't have to worry about where it's undefined. Okay, so you don't have to worry about where it's undefined, but you do have to worry about where it equals 0. So you're going to say 1/2, let's fix that. You're going to say 1/2 minus cosine of x equals 0. I'm going to choose to move the cosine over, so that would be 1/2 equals cosine of x. And we have to solve that particular equation. Now, first of all, we need to know the reference angle in which the cosine is 1/2. Some of you use unit circles, some of you use charts, some of you use triangles. You have to find which way works best for you. I personally use triangles. So I know that cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So the missing ratio there is square root of 3, and I know the angle opposite square root of 3 is 60 degrees. In radian form, which is all that we're going to want, that's pi over 3. So my reference angle is pi over 3. Now, there are two places where the cosine is positive. The cosine is positive in quadrant 1. In quadrant 2, it's negative. In quadrant 3, it's negative. The cosine is also positive in quadrant 4. So my reference angle is going to be a pi over 3 right here and a pi over 3 right here. So one critical number is just going to be pi over 3. Okay, go all the way around. My second critical number is going to be the whole circle. The whole circle, 2 pi, except for pi over 3. So if we put that into our minds, 2 pi would actually be 6 over 3. 6 over 3 is 2. So 6 over 3 pi minus pi over 3 would be 5 pi over 3. So my two critical numbers for this problem are pi over 3 and 5 pi over 3. So I'm going to put them on there. That to me is the hardest part of the whole problem. Now, picking test points. You have two options. One option is to actually pick our basic 45, 45, 90 or 60, 30, 60, 90 angles and work it that way. So you can definitely do that. You can also just change these to decimals, which actually is the easiest way to go. Now here's what I mean by that. Pi over 3. If you take pi in your calculator and say pi divided by 3, you get the number 1.047. If you take your calculator and you say 5 times pi divided by 3, you get the number 5.23. Now while we're calculating, let's calculate a couple of other things. This endpoint over here is 0, so that's just flat out 0. But the endpoint on the back is 2 pi. Well, 2 times pi would be 6.28. Now, if you have a calculator, remember you can use a calculator as long as it's on the allowed list. My best bet would be to find numbers that are inside this decimal range. For example, a number out here that we could pick would be 0.5. You could also pick 1. You could pick 0.75, 0.1, any of those would work. A number in here that I could choose is 4. A number out here I can choose is 6. Now, of course, you can pick any number in that range, not just the 3 orange ones that I've done. Now, what you're going to do with these orange numbers, remember, you plug the test points into the derivative. Your derivative for this particular function is 1/2 minus cosine of x. Make sure your calculator, if you're working it my way, make sure your calculator is in radian mode. Okay, so with your calculator, you're going to say 1/2 minus the cosine of 0.5. When you say 1/2 minus the cosine of 0.5, the value that you get is negative 0.37. More importantly, the value that you get is negative. Now I'm going to go back and change things up just a little. I don't have my calculator with me today, and when I worked this originally, I used the number 3 here. So I'm going to go back and change that just a little. So 3 is still between 1 and 5. You could have also used 4. That's 5. Sorry. 3 is between 1 and 5. You could use 3. You could also use the 4 that I placed there originally. But since I have these numbers on my sheet already, I'm going to go with the 3. So you would say my derivative is 1/2 minus the cosine of 3. In radian mode, that would give you 1/2 minus a negative 0.99. So that would give you 1/2 plus 0.99, which would give you a positive result. Lastly, you can plug in 6. 1/2 minus the cosine of 6. That would be 1/2 minus 0.96, which would give you a negative result. That's your sign chart. What you notice about this first one is that it's decreasing. This second one is increasing. This last one is decreasing. So let's write our answers for the top blanks. This one is increasing from pi over 3 to 5 pi over 3. This one is decreasing from 0 to pi over 3, and it's decreasing from 5 pi over 3 to 2 pi. Now let's connect our arrows up there. If I connect this arrow, I see I have a valley. So a valley means that's a low point. So I'm going to have a minimum at pi over 3. Okay, so again, I go down and then up and then down. For this second one, you'll see that I have a high point. So I have a high point at 5 pi over 3. Now, remember for this one, it asks you to find the y values. To find y, use the original function. Okay, the original function for this particular problem is 1/2 x minus the sine of x. The first value that I want to plug in is 5 pi over 3. You could also put that in your calculator as 5.23. So you have 1/2 times 5 pi over 3 minus the sine of 5 pi over 3. And if you put all of that in your calculator, what you should get is 3.48. Okay, it doesn't matter how many positions you round it out to. I just usually go with 2 for good measure. Okay, so then you can try it again with pi over 3. So you get 1/2 times pi over 3 minus the sine of pi over 3. And if you put all of that in your calculator, the value you get is a negative 0.34. And that's how you would do that one.